Assalamualaikum and hi to Sir Azzi and fellow viewers. We are Group 4 from PI080S42 and today we will be presenting our MAT097 group project assignment for Task 1. Let me introduce our team members. We have Nur Fariha, Nur Alia Umaira, Nur Dayana Alia, Nur Nuwaira, and lastly Nur Nazifa. This project focuses on the real-world application of first-order differential equations. Our chosen topic is the human population in Panama from 1975 to 1994. We selected this period because the population shows a steadily increasing trend. So in this video, we will walk you through our data collection, the derivation of our mathematical model, and an in-depth analysis of the factors influencing Panama's demographic changes. These are the data we collected from the World Bank database. We collected data from 1975 to 1994, which covers a total of 20 years. As mentioned earlier in the introduction, we selected this period because the data shows a consistent increase throughout the years.
So now we are going to walk through how we model human population growth using calculus. Let's start by defining our variables. We use PT to represent the number of people at any given years. Based on data we collect, the more people there are, the faster the population growth. In maths, dP over dt is proportional to the population's P. Now, we need to change this relationship to differential equation by adding a constant of proportionality, which is K. And to solve this, we use a separable variables method, which is we move all our p terms to one side and our t terms to other sides. Now, we integrate the differential equation. When we integrate both sides, the integral of 1 over p becomes a natural loss and k becomes kt plus a constant, which is c. To get p by itself, we take the exponential of both sides. This gives us our general equations, which is p is equal to ae exponential kt. A represents our starting point. Looking at our data from 1975, which we will call time zero, our population was 1732389. When we plug that in, A reveals itself to be exactly the initial population. So we get the general solution becomes P is equal to 1732389 exponential kt. Now we still need to find K, which is our growth rate. We look at our next data points 1 year later, which is 1976. The population grew to 1776935. We plug this number into our equation and use a little bit of algebra and natural logs to isolate K. As you can see on the screen, K becomes about to approximately 0.0254. This means the population is growing at about 2.5% per year. Finally, we get our particular solutions, which is it becomes pt is equal to 1732389 exponential 0.0254 times t. So by looking at the table, we can get the estimate populations by using our particular solutions, which is we need to plug in the t is equal to 0, 1, 2, and until 19 to get estimate population for each year.
Hi, I am Nur Nazifa. Now we are going to determine the number of population growth in Panama in year 1984 as a past. We get t is equal to 9 for the year 1984. So we substitute t in the general solution and we get 2,177,334 human, while the actual population in year 1984 is 2,150,782 human. From both of these value, we can calculate the percentage error, which is the measured value minus actual value over actual value times 100. So we get 1.235% for our past value. Next, we are going to determine the number of population growth in Panama in year 1993 as a future value. We get t is equal to 18 in the year of 1993. We substitute the value of t into the general solution and we get 2,736,559 human, while the actual population in year 1993 is equal to 2,650,099. From both of these value, we can calculate the percentage error and we get the percentage error is equal to 4.645%.
So, this is the graph of human population in Panama from year 1975 to year 1994. We plotted the graph based on the data we achieved in the Excel. As you can see, as the year goes by, the population of the human increasing. That's make the graph increase. Okay, now we will see the graph of the estimated population of human in Panama from year 1975 to year 1994. As we have been presented before, the particular solution equation that we got is Pt equals to 1732389 e the power of 0.00254 t. So, based on equation, we substitute the t value with the 1 till 19. As we substitute, we got a new value of y, which is we will plot a new graph based on the y new value. So, when we plotted the graph in Desmos, we insert the equation into the application we call the exponential growth graph. As we can also see, based on this graph, we can indicate the population increase as the time goes by.
Moving to step 6, analysis and discussion. First, we validate our model consistency. We compare our calculated prediction for 1994, which is t equal to 19, against the actual census data. As shown, the actual population was this, while our model predicted this. Although there is an overestimation of about 137,000 people, the model remained consistent. Both datasets follow a synchronized upward trend, proving that multi-ation growth model effectively capture Panama's population trajectory during this period. To measure reliability, we perform a percentage error analysis. Using the standard error formula, we calculated a margin of approximately 5.16%. In demographic forecasting, an error margin near 5% is remarkably low. This confirms that our particular solution is highly reliable tool for short-term estimate, proving a strong mathematical approximation of real-world growth. So why does this 5.16% gap exist? We identify three scientific reasons. First, constant growth rate. Our equation assumes K is constant, but in reality, Panama's growth fluctuated with economy shift. Second, rounding effect. We rounded K to 0.0254 over a 19-year span. This small adjustment causes a noticeable divergence in the final total. Third, model limitation. The multi-ocean model assumes unlimited resources. In reality, limiting factors like land and food supply naturally slow down exponential growth.
Now, let's look at the factors that influence population growth in the past. One major factor was improved healthcare and sanitation. Over time, Panama developed better hospitals, vaccination programs, and access to clean water. This improvement helps reduce death rates and increase life expectancy. Another important factor was economic opportunities, especially after the construction and operation of the Panama Canal. The canal created many jobs and attracted workers and migrants from other countries. This increased immigration, which contribute to population growth. In addition, urbanization and development in cities such as Panama City encourage people to move for better education, employment, and living standards, further increasing the population. Next, let's look at the factors that may affect Panama's population growth in the future. One key factor is economic conditions. If Panama continues to grow economically and provide job opportunities, it may continue to attract migrants, which can increase the population. Another factor is education and family planning. As education level rise and people become more aware of family planning, birth rates may decline, slowing the population growth. Finally, environmental challenges such as climate change and resource management that may also influence where people live and how populations grow in the future. And that concludes my analysis.
In conclusion, Task 1 has demonstrated that first-order differential equations are a powerful tool for demographic prediction. While no mathematical model can perfectly account for every real-world variable, our 5.16% error rate shows that the exponential model provides a very reliable approximation. We have also completed Task 2 using Excel to solve numerical methods, which further strengthen our digital skills. Thank you for your time and attention.